Hello everybody! Welcome to the latest webinar by MBF Bioscience. I'm Sue Tappan. I'm the Scientific Director at MBF. I also run the day-to-day operations at our contract stereology research facility, MBF Labs. I'm joined today by my colleague TJ Tetreault. It's TJ's first webinar. TJ.
Yeah, that didn't make me nervous by saying it's my first webinar. But like Sue mentioned, my name's TJ Tetreault, and I started here at MBF Bioscience just about a year ago last June, and I work with Sue at MBF Labs. I've worked closely with Neurolucida 360 over that time to ensure that we create a high-quality product. I also do a lot of work with our free trial process for Neurolucida 360, which has allowed me to test a variety of images submitted by a bunch of different labs and research facilities to see if our product would be a good fit for them. And then through that process, I've also had the opportunity to provide some live demonstrations of our software. And during that process, I've gotten a lot of feedback from, different labs and different scientists about what they think about the software and their input on some changes that we can make and some suggestions. And so we've listened to that and we've come up with a couple of features that we want to share today.
Yeah, so today we're going to be demonstrating the latest improvements to Neurolucida 360 with a special focus on large volume reconstruction. This is expansion microscopy. The image data was provided by Ray Gao, Ed Boyden, and Eric Betzig, and we used Neurolucida 360 to reconstruct not only the dendritic structures, but the dendritic spines as well. And with this expanded volume, you can see those beautiful dendritic spines, in particular the dendritic necks. They're just stunning. So we've made some changes to Neurolucida 360 to better model dendritic spines when you can see more of the dendritic spine neck, as well as make additional alterations to the software to make it easier to use with expanded microscopy tissue. We've got a lot of ground to cover though in the next hour, and before we get into the discussion continue the discussion of the newest features of Neurolucida 360, I want to take a few moments to cover some of the basic information about the webinar itself. We're always working hard to improve the software's functionality, but also your experience while using it. A few things that we've implemented recently include a refined user interface that's focused on making the tools you use most often easier to access. We've also created new help resources, including a dynamic search bar and additional ways for you to contact us for assistance. We provide in-software notifications about the new releases, so the software itself will let you know when there's a new version of the software. And we've improved the modeling of dendritic spines, especially with respect to expanded tissue, but it's true throughout any type of modeling that you would be doing. And in addition to that, we've made it easier to get your metrics from Neurolucida Explorer by providing a single button click from Neurolucida 360 to directly open your image or your data file in the morphometric analysis software, Neurolucida Explorer. These are just a few of the things that we've been working on over the past year, but we're really excited to tell you what we have been working on for this new release.
Yeah, and so one of the things that you'll see in this new release is our completely redesigned movie mode. And so we've applied intuitive tools to produce high-resolution videos. As you can see on the screen here, we can now navigate in tissue in 3D in a completely redesigned way. Another thing that we've worked on is visual improvements for dense networks in 3D. What you're seeing currently on the screen is a tool that we call Display Previously Traced Trees as Centerline.
That just rolls right off the tongue,
Yeah,
doesn't it?
it's smooth to say and it works just as smoothly. So what it's doing now is as you're tracing, the tree will retain its thickness and then all the other trees will be displayed as a centerline as the tool suggests. Another tool that we've created is the partial projection tool, which allows you to dynamically limit image and trace data in a single dimension. And lastly, we've made some algorithm changes in all three of our algorithms in both user-guided and fully automatic modes to increase speed and accuracy. And lastly, the reason why almost everybody is here today is for this large volume reconstruction mode. We're super excited to talk about it. And this mode has been created specifically to handle large image volumes and to allow a better reconstruction with more ease.
Yep. And so we're going to demonstrate each of these major functions and also address any questions that you have with respect to using Neurolucida 360. We're going to start first by working with large volume reconstruction.
And so reconstructing big data at high resolution is limited by how much image data can fit on the graphics memory card, and also results in noticeable slowdowns when transferring that image data between system and graphics memory. So by using the large volume reconstruction, our goal is to increase the efficiency and help reduce the time and resources and the frustration of reconstructing these large volumes by allowing a more accurate and a more efficient reconstruction, especially with files that greatly exceed our current limits. So in simpler terms, large volume reconstruction mode can be used by anyone when your data set begins to stress the computer's system resources.
So what do we mean by stress the computer's system resources? If you're using a machine similar to mine, my machine has a tremendous amount of CPU memory, and it's got a really nice graphics card. It's got an NVIDIA GeForce 1070, so it's an 8 gig graphics card. So LVR is going to make that machine operate better. But it's also going to make any other machine operate more efficiently because we're going to modulate how we're using the data, the image data, and the reconstruction process to better suit the resources that are available. So what does it look like? If your image is slow to rotate in the 3D window, or if you it takes a while you're tracing, you have these delays while the process of the image data is being passed over to the 3D window, that's a good opportunity to try out large volume reconstruction mode. You can also use it if you need to modify existing reconstructions from large volumes. So if you've already done a reconstruction and you want to either refine it or inspect it at its native resolution, this is a tool that will really help you do that. And then finally, another area where we think that this will be effective and helpful is when you have neuronal features that vary enough across the image as a whole that a single set of parameters is insufficient. It's difficult to get an appropriate reconstruction in all areas of the volume with a single set of parameters. So, for example, if you were detecting dendritic spines in a pyramidal cell and you've got apical dendritic spines that are really densely packed and closely packed together, you may have good success using a particular set of parameters that just don't operate with the same amount of accuracy on the basolateral structures where the packing density of the spines looks different. And so this is a way that will make it a lot more intuitive for being able to modify the parameters to suit the image data that is representative of the neuron that you're looking to get that morphometric data from. So the image is just part of that process. We want to get these numbers fit to the neuron that you're actually interested in looking at.
That's right, yeah. And Sue briefly touched on it, but just because this is called large volume reconstruction doesn't mean that it's only for large volumes. If you're working with a file that is really dense or really complex, this might be a really useful mode for you because you'll be allowed to take and generate little subvolumes of the larger, more complex areas. So if you have an area of focus or an area of interest that you're really trying to reconstruct and you're having a hard time, it might be easier to take a small section of it rather than working on the entirety of the image at once.
The one of the developers used an analogy that I'll just see if this helps. He reflected that this is similar to eating a pie. You could eat the pie all in one sitting, or you could take smaller, more deliberate bites and actually be in more control over each individual bite. So in this case, what we're doing is we're taking the entire image volume, and instead of having to swallow the whole thing at once by making your graphics, your GPU display it at once, we're improving that process by allowing you to specify at what resolution you want to see how much of that data. And so that's what we're going to demonstrate right now. So the first things first, if you are interested in using large volume reconstruction and you are a Neurolucida 360 Studio owner or user, you have access to this feature immediately. There's no additional, the only thing you need to do is to contact us. This is as provided as part of your subscription to the Neurolucida 360 Studio package. So just contact us to enable that new function. Once you have it, there's a couple of other points we just want to go over before we get into the demo. We want to make sure that the image data is an image stack that has internal scaling. So if your image data right now is a TIFF series, we would like you to convert that image data to a stack, in particular a JPEG 2000 stack, and specify the scaling. If you already have your data acquired as a CZI or an ND2 file, for example, so some of the other microscope companies with embedded scaling, then you're good to go. You'll want to be able to store that file locally on your hard drive on the machine that you're running Neurolucida 360 to improve the access of the image data to the processors for passing it back and forth. So having it closer will make everything faster and easier to use. Because this is complicated, large data, we have found that this is something that you go back to, and it's not something you finish in a single session. You'll come back to it multiple times. And so creating a profile to be associated with the desired image really streamlines that process of being able to resume work with this particular large data set. And finally, we're going to recommend that you reconstruct each subvolume completely before generating a new one. This allows you to make the best use of those smaller bytes that you're taking at that individual resolution, that high native resolution, and it streamlines the process. You don't have to remember where you need to go back to.
What we're going to do now is we're going to show that process. And so right off the bat, you can see right here that in this workspace ribbon, the reconstruction mode is already available. That's because we've already contacted NBF since we're there. They've provided us with access to the large volume reconstruction. And this, as Sue had mentioned, this profile has been previously set up for us. This is completely brand new, so we have not done anything with it other than just opening the program. So from here, we're going to go to our workspace tab, follow the ribbon until we find the reconstruction mode, and start. And so right off the bat, you're going to get this window that opens up, and you're going to click on the file menu and then locate the file where it is stored on the local machine. Once that's opened, then you're going to specify how large you want that main window to be. And so for us right now, we're working on one single monitor, which is why we're changing the dimensions from the previous to 750 by 750.
Yep, and the size of that dimension is actually modifiable, so you can change it as you're working, or you can make it a set value for an individual file, but you can adjust that. And again, think of that subvolume as how big a byte you're taking of the image volume. And so if you've got a high bit depth image, you may want to have a nice small volume so that everything is as fast as possible. And
so when you do start large volume reconstruction, there's going to be a bunch of tools that are launched by default. And so the one that I just moved onto this window is our large volume reconstruction window. This is going to be where you're going to be generating those subvolumes and specifying where you want the top and bottom to be. As well as a navigation field, which you can change the Z depth of the space that you want to jump between to find the top and bottom of your cell. And that's going to be happening over this main window where you can see the gray. If you were to use your mouse wheel to scroll, you can see a little bit of change in that main window. We're not seeing anything right now because we're not over anything. And that is something that you can see right here in our macro view. I'm going to expand that a little bit. But in our macro view, you can see the base of our cell. You can see the areas in which, where it is. And so if I go over the main window again and use that scroll wheel, I can focus in and find the cell. And so the macro view is a way to navigate through the entirety of your image with ease. And lastly, the last tool I'm bringing over is our Z meter. And that's going to be how you navigate through the depth of your image in that main view. And so to reconstruct, all you have to do is find an area of interest, use your Z meter and your scroll wheel to find the top of the cell, to find the top of where you want to generate that subvolume from. Click the Set button in this large volume reconstruction window, continue to scroll, and then once that's out of focus, then you can set your bottom. And then all you have to do is click Reconstruct and wait.
And so we got a question at the time of registration wondering about how to adjust the black point and white point and gamma of the images while you are working. If you're working in the large volume reconstruction mode, you can see here in the histogram that you can select the black point and white point and the gamma to adjust as necessary. So if you want to enrich a particular area for reconstruction, you can make these changes prior to hitting the reconstruct button here. Once you have the reconstruction button, the volume is now created here in this 3D window. You can see that this looks just like Neurolucida 360 that you're used to using. And in fact, it's going to operate exactly the same way.
That's right. So if we go into our user guided mode and trace it just like we normally would, we'll have that selected, and then we'll trace it like we normally would. And so you can see it tracing, and like Sue had mentioned previously, you want to reconstruct as much as possible to have an accurate reconstruction as well as to get the most out of the mode.
And so you would identify the spines, for example.
Yep, and since we've worked with this image before, we know the parameters that will work best. And so something to note is that the keep existing spines is on by default, and that's so as you go through and generate different subvolumes throughout the entirety of your image, the spines will remain in place without being overwritten or overdone.
Yep. And so now that you've reconstructed the dendritic spines in this subvolume, go get a new one.
Yep. So as I'm navigating, I'm going to be using the mouse, or I'm going to be using the arrow keys on my keyboard, and I'm just going to use those to pan over. And once I'm there, I can look for the area that's out of focus, set my top, and then I'll go back. And it's very important that you have an area back in focus of where you've already reconstructed. That way you can create a connection.
You just want to make sure that when you're collecting that next subvolume, you want to go all the way through the structure so that it's out of focus, not just at the same region, so that you get a nice contiguous, you get the structure that you're looking to continue with completely available for reconstruction. And so you're basically going to repeat this process. So we are reconstructing this volume. Isabel is asking a question about wanting to know more about this particular image volume. This image volume was provided by the Allen Institute for Brain Research. This is a cell that had been previously recorded from, and the step size is 0.28. And I'm just going to take a look to check out the XY location as well. So the scaling information is this was acquired at 100x. So this image is a high resolution volume, and it's actually quite large. because it spans not only the apical dendrites, but to the soma, the basolateral dendrites, and inclusive of the entire axonal arbor for this, for the dimensions of this image volume. And so this is quite a large volume. And so now that we've reconstructed a little bit point by point, you don't need to reconstruct in any particular order. You can if you want, or you can navigate to any particular location. So this is why we also think that this is handy if you want to revisit a reconstruction that's already in process. So you can load any image data that you can currently operate with in Neurolucida 360 and then some. So in this case, you can see that we're working with a bright field image. So this cell was recorded from and then filled with biositin. You can use multi-channel fluorescent data from a 2-photon, from a confocal, light sheet data. We haven't found any limits on the size of the volume that you can work with.
That's right. As long as you can load the image data into Neurolucida 360, large volume reconstruction mode should be able to handle that as well.
I'm sure there's plenty of you. Oh, I got a little distracted. So when you reconstruct your somas in bright field data, just make sure you turn down the sensitivity quite a bit. Otherwise, you get a blocky soma. I just clicked out of habit, but you can see that just turning down the sensitivity gets you the right soma modeled. And so you can use this process literally to hop anywhere you want. So
that's right. So in the macro view right now, Sue's zooming in on an area that it appears that there was nothing. But as you go through and focus a little more, depending on which direction, there might be processes within that area that you might not have noticed if you were looking at it through the entirety of the image. So there was something that was coming into focus, and you can see it slightly there. There you go.
There.
And so as she's scrolling through, you can see that the axon is actually present there, which would have been very difficult to find in the entirety of the image if you were just to load this in the 3D window.
Yeah, there's hundreds of image planes here. But the axon itself only traverses, in this case, 72. So, why have to wade through the entire X, Y, and Z depth of this volume when you're interested in reconstructing that fine structure of the axonal arbor? So if you have a very complicated structure like the axonal arbor, where that's really fine and tortuous and changes the way that it traverses regularly, this tool is going to be a savvy way for you to quickly and easily work with this volume. And so in this case, in 2 clicks, I've reconstructed this axonal volume here. And now I'm going to detect the varicosities. So if you look, you can see all these beautiful varicosities along this axonal structure. And we added varicosity detection last year. And it's very straightforward to do. And you can see how it just quickly models the perturbations in the axonal process. And so if we're going to continue this now, again, if you specify an area just above the volume, the structure you're interested in reconstructing, and then I hit the button to send it over to the 3D volume, and that's a method that will make it very straightforward for you to keep track of something this fine in such a large volume. We have a question wondering if you have to use user-guided or smart manual during this reconstruction process? And the answer is no. You can use automatic tracing as well. And so in that case, you would just select automatic tracing and select the algorithm that's going to be appropriate for the reconstruction. In this case, because it's bright field data and it's very tortuous and punctate, directional kernels is the algorithm that I would recommend. And so I'm just going to hit trace and see what happens. And it's going to reconstruct the entire structure there. So it actually reconnected that so it took the trace that was present from the previous volume, connected it, and continued it. And so you could do this as you go very quickly and easily. And so now if we wanted to add the varicosities, we can. And so now look what we've created here, all in no amount of time. It's super easy. So let's go over one more time how to do this process of finding the region that you want to work with and creating the subvolume to send over to the 3D environment. So I'm using the macro view to see where I am. These aqua boxes are temporary and they let you know where you've been. So they're only present during that initial session.
That's right, yeah. So once the data file is saved, you can bring it back into the large volume reconstruction mode or even just into any sort of MBF software, MBF bioscience software like the Neurolucida Explorer, like our analysis software. And those aqua boxes are going to be gone. So they're only going to be present for the time that you're working in this current session. And then another thing to note is you can see in the macro view that there's a sort of a gray box next to these aqua boxes, and that's going to be specifying what you're seeing in that main window. So as you move through the macro view, that gray box is going to be representative of what is, I guess, sent to the main window.
Right, that's what you're looking at present, so that's what's being displayed. That's the subvolume display. And that's what we're going to be specifying to collect to send to the 3D window. And so to do this process of creating a subvolume to generate a reconstruction from, you'll navigate to where you want to go in the macro view. Bring the region, the item of interest. So in this case, this axonal fiber here, we want to bring that into view and then just back off it just a little bit so that you're just above it. Set the top and then navigate through it till it's no longer present. And set bottom. And that tells me the subvolume is 40 images. I'm currently using the mouse wheel focus to jump about 2 microns with every click of the mouse button, so it's really easy to navigate. But what you can modify that, but when we create the subvolume, we're always doing that at the native resolution. And so now that we're happy with the dimensions of our subvolume, we're gonna say, okay, now let's take this into the 3D area for a reconstruction.
So one question that I'm seeing is, with this large volume method, can we link together different segments with the edit tool?
Absolutely.
Absolutely, yes.
Yep.
So do you want to reconstruct up to a point and then use that edit tool to connect them?
Sure. So I'll just, because I have the mouse right now, I'll just demonstrate the reconstruction here. Oh, it just happens to be just about the same color.
Beautiful.
So I'm going to get close here. So I'm really zooming in. And let's say they were 2 independent segments like that. You can go into edit mode and just connect those 2 guys right up like that. And you can see that the connection was made in the main window. The connection was made in the 3D window. And if we go to home, you can see all of the structures that we've reconstructed so far. So we've jumped around a little bit. Here's the soma in pink, and then this orange structure here is part of the axonal arbor that we've reconstructed, and then the dendritic arbor is over here on the left. And so you can see this is a process that you can repeat to at will. So you can save this data file and resume it at any point. Isabel asks if the software recognizes the boutons. It does. We're pretty excited about that. So the structure, so the varicosity module here, so this button here allows you to detect the varicosities along the axonal structure. And if you detect, you can see that, I'm going to zoom in so you can see what we're finding here. And you can modify the detection parameters for the ratio as well as the length, for the thickness and the length ratio, in order to figure out, you know, how large a varicosity you want to identify. And so it's very straightforward and easy to do. The software itself has also been, we keep track of the surface area, the volume, the density of those varicosities, and we report all of that in Neurolucida Explorer as well. All of these features are present in the Neurolucida 360 Studio version. So large volume reconstruction, as we mentioned, is a new part of the Studio package, and varicosity is also something that was added to the Studio package when we created it last year. So Alexandria is asking about whether or not the software functions with fluorescent image data, and yes, it does. We can show you that. Do you want to switch over?
Yeah.
We have one preloaded. There's a few other people who are clearly software mavens who have some important, questions about how multi-threaded the application is, and what purpose, whether or not you can use parallels with a Mac. And we'll take those questions offline, but basically it depends on the process and it depends on what you're doing. Neurolucida 360, because it is a graphics intensive program, we don't recommend that you run it on parallels on a Mac. We can't necessarily control how well your experience is going to be in a situation like that. Luis is asking if we have to reconstruct the trees before detecting spines or varicosities. Yes, you always have to have a tree structure before you can detect spines or varicosities. And it does not change any detections that were previously done. So if you have worked in, let's say, the apical area of your dendritic tree and detected spines, because we have by default the keep existing spines checkbox selected, you're not going to overwrite that with this new detection. So you are protected from having to do that. If you get to a new area and you need to test a couple of different parameters until you find something that's going to work well, you can select the clear last button in order to wipe out these initial changes so that you can go back and forth a little bit. Okay. Naomi is asking how thick the reconstruction is. It's about, I think, 300 microns from top to bottom. So the top of the stack to the bottom of the stack. The volume that we're looking at right now is 300 microns. This is an in vivo 2-photon image, so you can see the impact of the resolution at the time of acquisition. So the impact, you can see that the dendritic spines, as they're detected, have this mottled appearance, and that's because of the number of voxels that are present in this volume. When you have your reconstruction, Neurolucida 360, you can select a single button click to send the data file to Neurolucida Explorer. And when you do so, Neurolucida Explorer will automatically calculate hundreds of metrics for you, including branch order, density of spines, if you had captured spines, per unit length of the dendrite, according to its branch order, according to the distance from the soma. You can do shoal analysis. There's all sorts of things.
Okay, so like we had mentioned earlier, there are some other features that we wanted to take time and show today. To start off, we'll do the display previous trees as centerline. The ever so smooth and properly named tool.
We're not very creative, unfortunately.
We've come to find that the more straightforward the name, the more intuitive it is to use. And so you can see as I'm beginning to trace this dendrite that the rest of them have started to display only that centerline thickness, whereas the one that I'm currently tracing is retaining its thickness. And as I end this tracing, the rest of the trees will return to their original thickness. And then if I were to amend off of this tree, you can see that the entire structure of that tree is going to remain at that thickness, where the other ones, the other trees, are going to retain that center line. And then once the connection is created and that tree is done being traced, everything will return to its original thickness as intended.
Yeah, so this is a way to make it easy to do the individual branch reconstruction or editing that you may want to do in a dense or complex area, letting you know what's already been traced so that you don't need to be concerned about whether or not it is something to connect to or not. And it is just very straightforward to get in there and do. You may have noticed that while TJ was tracing, you saw these little bubbles that showed up. Those are in user-guided mode, that's the algorithm that is providing an expected path for the process, for the trace, based on a pre-analysis of the image data in the volume. And so the algorithms are taking a look at the neighboring voxels based on where you are to say, okay, well, where is the dendrite itself? So it helps make a smooth and easy reconstruction using those. You don't have to use user-guided. It makes a very good demo to show what's available. You can use automatic reconstruction or smart manual. And for user-guided and automatic, remember that there are 3 algorithms that are at your disposal that you can choose to use based on the characteristics of the image data itself. So those types of structures, you may find that you want to switch algorithms while you're tracing as you go from one region to the next, for example.
Yeah, that's right. As the trees change, it might be beneficial to change the method that you're using. So directional kernels may be best in one instance, where it might be better to use Reber's crawl to get a larger section when those diameters do change.
Yep, or voxel scooping.
Exactly.
So each of the 3 algorithms differ in sort of what they're paying attention to and what weight they give to the different portions of the image for tracing. I'm going to show you how easy it is to get some numbers out of this reconstruction, since we have a nice, beautiful, completed reconstruction here of this cell. This cell was filled as well. This was injected by Javier de Felipe's lab and reconstructed as part of the Human Brain Project, I believe. And this reconstruction is just stunning. We didn't detect all the spines, but that's also been done on another version of this file. And so once you're happy with your reconstruction, you just go up to the top panel here and select this icon here to open the data file in Neurolucida Explorer. So that single button opens the data file immediately into Neurolucida Explorer. This is where you get all your analyses. And so if you were interested in shoal analysis, for example, you can get all of the numbers based on the ordering of the branch order that you select. So we have centrifugal as a default, but there are other ordering schemas that you can use. And then you can see that as you select individual data in the output, it'll highlight the representative shoal ring, so you can see exactly what we're talking about. Okay, so all of these numbers are generated for you automatically. If you were interested in branch order, for example, that would be one way to calculate it as well. Oh, let me remove and close all. And so if we go back and I just show you color by branch order, I can
There you go.
demonstrate that you can navigate by branch order too. And so these are all the primary branches in this particular file. And as you want, if you want to explore this on the basis of branch order, you can just navigate up the tree in order to see where all of those branches are coming up. And so we're giving you ways to explore your data, not just in numbers, but in visualization as well.
So another tool that we had mentioned previously was the partial projection tool, which has become just immensely helpful when reconstructing in dense networks. It's honestly one of my favorite tools that we have, and I found it to be so useful. And it's under this image button, and it's just right here, partial projection. When you turn that on, you can see that a lot of the image may go away, but that's part of the tool. It's limiting how much is going to be shown in the 3D window at one time. So in this y-axis, you can see a really good just way that the tool functions. It's allowing you to look at a portion of your image data at once.
Yep. And so what it allows you to do, all the data is there and loaded in the 3D window, and what we're doing is we're just limiting how much is shown so that you can more easily focus on the area that you want to be working on at a given time.
And so you can tell the program how much you want to limit. So if you are okay with working with larger sections, you can change the thickness of what's being shown. Or if you want to work in smaller sections because you're working with such a complex network, you can really get that down to a limited number to only show a small portion of your image. And that can be done either with these arrows by extending them out or bringing them back, or with this thickness. If you have a specified thickness that you'd like to work with, you can always input that, and the program will allow you to do that. And like we previously mentioned, you can do that in all three dimensions, so X, Y, and Z. And you can do this as well for an editing technique. You can hide your tracing and re-show it to see if you're accurate with your reconstruction.
Mm-hmm. While we're here, you can see that you can make display adjustments to the image data as it's displayed in the 3D window as well. So you can modify the black point or the white point and gamma on a per channel basis, and that channel is RGB. So if you want to limit or make adjustments in ways that the algorithm can see, you'll actually want to do that in the image adjustment window. This just changes how it looks for you. The algorithms themselves actually operate on the original image data in the main window. But we have ways so that you can customize that to get exactly what you want. One reason you might want to adjust the black point and white point perhaps, or make some of these changes, is if you wanted to make a movie.
Yeah, that's right. And so that's a great leading way, a great segue into our last feature, the movie mode, which, like we had mentioned before, has been completely redesigned. And so this new user interface, you can start by simply clicking the set start position. And what that's doing is it's telling the program that you want this to be the initial start point of what you're going to be viewing in that movie. And so next, if I zoom in on a specified area and do a simple rotation, I'm going to just click this add clip button, or I can click this set next position, and that's going to create a clip for us. And so what you're doing with the program now is you're telling it where you want these endpoints to be for your movie. So as I zoom in with pivot point to focus, to get that new focused center point, I can create another clip. So what the program is going to do is it's going to jump from point A to point B, but it's going to create that smooth transition for us. So I'm going to just run through quickly and show how that's being done. And like we had mentioned before, there is going to be a delay in the image or video right now, but hopefully that will be different when we have that final video available for you. And so lastly, if I just click home and click the add clip button one last time, we have a full video with all of the necessary movements done, and we've only had to click the mouse 5 or 6 times. And so it's nice to know that the program is not going to follow every movement that you do. So I can rotate, I can zoom in, I can pan through the image, but the movie mode isn't going to follow or capture any of that until I click the add clip button. So basically you're setting up the position that you want, and the program will intuitively kind of stitch those together.
Yeah, it's going to calculate the path that's necessary, the vector, in order to get from position A to position B. So it'll create a smooth transit from one location to the next, which is great for people like me who can't make up their mind about what they want to see and are constantly moving their mouse around.
That's right. And so you can also edit these clips individually. By right-clicking on it and using Customize Clip, we can actually hide the tracing right away. So now when you go through, it will show just the tracing, and as we get into that next clip, it'll show the tracing one more time. And now I'm going to use this split clip function, which does just that. It will allow us to split the clip at any point. And so we'll go about halfway, and we'll hide the tracing on this next one. And so now, as we go through, we can see that it'll hide the tracing, re-show it, and as we zoom in one last time, it'll hide the tracing again for us. And so these clips by default are going to be at 5 seconds, but that can also be changed. You can extend them longer, or you can make them shorter, and that will also help with the transition from one clip to the next. Yep. By making it longer, the transition will be a little slower, and by making it shorter, the transition will be a little quicker.
Yep, and if you also want to have a nice, smooth, slow transition from one location to the next, you can put in intermediary points as well.
That's right.
That calculates a different, vector in order to get to those different locations, and so that will help slow down the change in the viewpoint, the zoom.
And so another cool little feature that we have is, because these are written out sequences, you can actually save the sequence and never have to create it again. You can save that, and it'll save as an XML file, and then you can load that in anytime you're working with a movie mode. So if you're really interested in doing just 180 degrees or 360 degree rotations, you can save a script, and you can load that in for any image file, any data file, and it'll follow just as it was written previously.
Yeah, it doesn't matter the dimensions of the image either.
That's right, yeah. And so another good thing about it is, say we went back into our 3D reconstruction and we wanted to make some changes, we can change the color of all of these dendrites to a nice bright yellow color and go back, and because this is the same instance, the program will remember the sequence that we've previously written. Or like we had just mentioned, you could load that back in and it would follow suit. And so now that we're happy with our reconstruction and with our video, we can click this little export button and we can save it as an MP4. And so we've done this previously, and we'd like to show you guys what we created.
And again, this will be much smoother, not during the broadcast. And so because this is a data file, we can continue to revisit this data file and make changes as necessary. So if you wanted to, you could have this entire structure here reconstructed, and then come back in and add spines if you wanted to, or varicosities, or synapses. You can continue to enrich your data file over a period of time. If you're using large volume reconstruction mode, that's an easy way to get the subsets of data for enriching particular areas as well. I hope we've been able to demonstrate at least a part of these newest features. In particular, the large volume reconstruction mode, I hope, is something that is going to be of great use to everybody. So in summary, we talked about the large volume reconstruction mode, and we've created it to reduce the time of reconstruction without having to increase your system resources. Of course, having a more powerful machine is what we all aspire to. Who doesn't want the latest and greatest?
Yeah.
But this large volume reconstruction mode is a way to make the most of what you have right now, and it will only improve as you continue to upgrade your machine, either with solid state hard drives or with a PCI chassis or anything like that. Those are things that can only make this process better. And we've also made visualization improvements to improve the inspection and correction capacity of the software itself. We know that it's not enough for you just to create a reconstruction. This reconstruction has to be accurate. And so this is an important aspect of why we create the tools that we do. And finally, the new movie tool allows you to create a dynamic video that allows you to show off all your hard work. So we hope that you find that to be helpful as well.
And so as your data gets ever larger and more complex, we're going to be innovating right alongside you. And so this release is just the first iteration of planned efforts to accommodate even larger data sources that we see come in.
We look forward to providing you with updates throughout the year. Thank you very much for your time and attention today. If you're a current user, I hope this webinar serves as a way to help you best utilize what we're creating for you. And if you're interested in Neurolucida 360 but haven't used the software, we invite you to try it today.
Yep.
So one thing that we attached to the GoToWebinar, we've posted a handout. So the handout has a couple of slides with clickable links, including this guy right here. So if you want to try large volume reconstruction, go to this website and then select the choice that best matches where you're at. So if you have Neurolucida 360 Studio, you just need to contact us and we'll get you going with large volume reconstruction. If you own Lite, Essentials, or a custom version of Neurolucida 360, we can get you started with a studio trial right now. TJ will help get you set up right now.
Yep. And if you don't own Neurolucida 360 yet, feel free to request a free trial. I'll look into that. I will be a part of that process with you. And as long as you're willing to join, we're willing to work with you. Yeah. So we really look forward to anybody who reaches out, and especially the interest that we've gauged from this webinar.
Yeah. So we want to thank the National Institute of Mental Health. We got SBIR funding support for the creation of Neurolucida 360, and we're very excited to continue to innovate in that direction. We're also grateful to the collaborations that we have with many people, many of you researchers that are currently online, and we appreciate it very much. The Allen Institute for Brain Science provided the allowed us to use the image data that we demonstrated with the large volume reconstruction. The expansion microscopy data was provided by Ray Gao, Ed Boyden, and Eric Betzig. Javier De Felipe had that beautiful pyramidal cell that you saw. That's a human neuron in particular. And some of the screensaver, images that were playing prior to the start of the webinar, those are NeuroArt submissions, and those have just been a wonderful way to rejoice in the beauty of the brain, and I invite you to check that out. If you are going to any of these courses, I hope you'll stop by and see us in person. Meet us face to face and tell us what you like and what we can do better with not just Neurolucida 360, but any of our applications. I'm going to be at the Cold Spring Harbor course in Asia, in Suzhou, in a couple of weeks. And then we're also going to be at FENS in Europe. If you are going to Berlin, stop in and say hello. And if you want, just stay an extra week and go to Munich and go to the tissue clearing workshop there. We will be at the Society for Neuroscience, just like we are every year, and we very much enjoy having an opportunity to meet you in person. In fact, I'm hoping to convince TJ to come to SFN this year. So.
I really hope I can make it. I wasn't invited last year because Sue didn't trust me.
Oh, that's not true.
But, hopefully this year I've gained enough of her confidence to invite me. And lastly, Sue's going to be attending the winter conference on brain research out in Snowmass. She had a wonderful time last year, a little accident skiing, but she's going to go back. She's going to try the mountain again. She's going to do her best and
hopefully keep both wrists intact this
exactly,
year.
Yeah.
Those aren't the only meetings that we're going to. Please follow that link if you want to see where else we're going to be. And maybe you're hosting a course or you're doing a workshop. If you want to use Neurolucida 360, get in touch. We'd be happy to work with you. I think that would be wonderful. If you have any additional questions that you're just dying to get an answer to right away, just let us know. We're so excited that you joined us today and are very much hoping that you enjoy the latest version of Neurolucida 360.
Yeah, thank you guys so much for joining us, for the questions that you've asked, and for helping make my first webinar go so smoothly. Thank you guys so much for joining us, and have a great rest of the week.
Bye, everybody.